Welcome. Thanks everybody for coming on board and listening to me discuss my journey. My name is Joe Marinfar. I'm a dentist here in Phoenix, and I'm going to be discussing digital model-less all-on-4s. My passion has always been implant dentistry. My passion has been full arch, and I'm just fortunate to have a good team that supports me and good partners. A few years ago, I started changing my workflow and going from analog models into utilizing more of a digital workflow. And the digital workflow for me always starts with the CBCT and then intraoral scanning. And now we've added photogrammetry and chairside printing. And the whole idea of this lecture is just to show you step by step what I do. And you'll see the equipment that I use and just have a feel of what you need to do this for your practice. So in about 4 or 5 years ago, I started my journey as far as teaching. I've always been teaching small classes, but about 5 or 6 years ago, I started teaching in a homeless shelter where we were treating underserved and the poor and underserved. And we started doing a ton of these surgeries. We were doing about 6,000 implants a year and doing it analog way. And we thought a better way of doing it is to, incorporating intraoral scanning and photogrammetry. So we started doing that. And in 2020, I left and I started my own live implant surgery center called All-on-4’s and dental implant education company, where we do live training for doctors from all over the country. And these are all my cases and my workflow. So with every patient, there's a plan. With every plan, there's a workflow. And that always starts with a CBCT and some kind of a software. What I'm going to share with you here is a screen recording of one of my patients. And it's really here what I'm using is, within my practice management software, which I have Dentrix, and here is DTX Studio Suite. In the DTX Studio Suite, the nice thing about this is I can locate and I can place all my files. So no more drag and click, everything gets incorporated in this software. So all my CT scans, all my photos, all my pre-designs, and also all my treatment planning is incorporated in the DTX software. So what I do is within the software is as soon as I bring the DICOMs up, it comes up on an MPR screen. And in this screen, I can locate the jaws and I can, drag my lines. And what it does is, before I would have to look at the software and then drag the DICOMs and put it in another planning software. Now with this software, it allows us to do it all in one shot. Some of the stuff actually my team members are doing this now, where, Diana here, she came to us for a full arch rehab. The upper jaw that was done first, my nonprofit, then we did the lower jaw. So now with this new software, I can actually plan the nerve, plan everything. And I would say probably by the end of the year, this software will have AI built in where it will actually, the nerve will be done for you. The teeth numbers will be done for you. You take all the PAs, it will number them for you and it will actually organize it. But what I'm doing here is just basically, as soon as I see the patient, I can go in right off the bat and start my design. So in the same software that I have, where I keep all my photos, my intraoral scans, and my DICOMs, I can use a DTX Studio Clinic here and actually plan my case. And this is going to be for a lower all-on-4. And then we're going to transfer these files then actually into utilize the X-Guide. So the one thing I'm looking at here, I'm looking at the jawbone, I'm looking at the structure, and I'm looking at creating a file and a folder for a patient with all the intraoral scanning, so I can communicate. So this is something I can communicate with my lab, I can communicate with my colleagues, and even with the patient. So having the ability to bring all these screens in within the software, it makes my job easier for my team members. And this is open import, open export, and is centrally stored in one location. So just the ability of doing this, it makes it smooth and very efficient. And I have access to this in all my operatories. Once I do that, I utilize my other software, which this is, again, a click of a button, it go from a DTX Studio Clinic into DTX Implant. DTX Implant is, for you guys who don't know, is really, it was the old Nobel clinician. And so what they've done is they merged these softwares together. So now what I've done is, and again, this is fast forwarded, but it took me about, I would say, 4 or 5 minutes to plan the implants. Now I'm bringing it into DTX Clinic, where I bring in my intraoral scan. And in this case, we use the MEDIT. And depending on the kind of data you get, depending on the scatter, the software can, through its AI, locate and diagnose and find its own fiduciary points. But in this case, because of the scatter, it did not. So what I do is I just simply clean up the data a little bit, and I just pick my own fiduciary points. Once you click the points, you transfer on both screens. So you're clicking on the intraoral scan, and I'm clicking the DICOMs, and the software will run through its diagnostics, and it will verify the merge. If it verifies, it will merge it together, then I have to look at it and make sure that it's complete. And the way I do this, I just look at the red line. If the red line is totally intimate with the tooth structure, then I know I have a clean merge. Then I know I have accurate data, because either you're accurately accurate or you're accurately inaccurate in this case. So now I have my implant positioning, I have my tooth positioning, I have my nerve, and I can go through and fine tune my design. And in this case, I can go through, and what I'm doing is I am trying to make this as an FP1, because what we used to do was do these cases as FP2s, FP3s, because knowing that all-on-4's, we used to think we need 15 millimeters for bone reduction. Nowadays, with the chairside printing, with the compression strength that we're getting from these monolithic prints, I'm not doing as much bone reduction, which is giving me better prosthetic, better result, and less bone reduction. So here I have the library. So I'm putting straight implants in the posterior. So no angulation needed. And therefore I can just use multi-unit abutments, which has a color height that is less. And on top of that, we go straight for our prints into we go directly to multi-unit. So I have a lot more restorative space, which is nice. And that's what I really like about the software. I'm getting a message that the screen is blurry. Is the screen blurry to you?
No, looks good to me.
Okay. So now by doing this, I can predictably plan these cases. And again, we work with a lot of different team members and our colleagues. So then I have a really nice file I can share this with my referring docs, with my patients. I know exactly how much bone reduction I want to do. I can see where my soft tissue is. So that's really a beauty about this software. And the new feature that they've added to this is my reduction planning, where before I am guessing, right? Or I'm ordering a guy to do my bone reduction. Where here now, what I'm doing is I'm using the bone reduction plane, and I can just simply go through and figure out exactly how much bone I want to reduce. It's very easy to use, and it's very predictable. And again, you can see here is I'm not reducing that much bone. And some areas where here we would reduce upwards of 5-6 millimeters just to put angulated implants. And I'm doing that less and less now. So by doing this, it gives me an idea where I want my bone reduction, and this can be transferred. I can transfer that into my navigation unit, my X guide, or I can just leave some markers and just some measurements. So at time of surgery, I can duplicate this in the mouth. And by doing so, it just makes my job a little bit more predictable and again, less trauma to the patient and more predictable results. As I'm doing this, again, I can bring in my soft tissue data. I can look at my multi-units. I can put in my cylinders. And it really, as far as it makes it a really a good restorative driven surgical protocol. Once I'm done, I just, I finalize this and I can go through and again, if I need to, and in this case, I did not bring any photos in, but you can bring your photos in, you can bring in other scans so you can compare if you need to, but it has a really nice workspace. So, so now, once everything is done, then what I'm doing right now is going through and I can go ahead and create a report and I can go through. The nice thing here is everything is documented for now. So part of having this software allows me to properly document, especially for these large cases. So once this is done, I can share and I can export, and this can be exported then to XGuide, and then I can do my my procedure. Now, there's different softwares out there. And again, for me, this is just something I started using about 10 years ago. And the nice thing is with the upgrades, with the updates, it just makes my life easier. It's easier for documenting, for ordering parts, and for keeping an inventory. So it's just a nice tool to have. And especially now within the DTX family, everything just stays there. Now, you can utilize different softwares for your planning, and but for me, this really works really well. So now this is really, so once this is done now and everything's is transferred to XGuide. So what I'm going to do is just close this out and pretty much take you through Diana's journey. Now, for Diana is so pretty much I record this whole surgery, so you kind of see step by step, what is it that we do. So everybody's journey starts. Everybody gets a cone beam for our purposes that needs the implant. We don't use the cone beam for a screening tool. We use it for a diagnostic tool. The cone beam I use in my practice is I have 2 iCats, and I have an iCat Next Gen. I have an iCat Flex, and then the OP3Ds. So once the scan is taken, I go through process and I take my photos, and the intraoral scanning is done. This is key because I have a designer in an office where all the photos and everything is gathered. He will actually start the design, right? And this is done ahead of time. And that way, when I do my surgery, then the day of surgery, I have the design completed. In the morning of surgery, we start with the XGuide. It's calibrated. Again, here, this surgery starts at 7 a.m. So around 6:30, Linda comes in and she go ahead and she will start calibrating the XNav. And it's really step by step. And what it is the XGuide itself is, imagine it's a very large photogrammetry unit. So as I'm getting a patient as we start anesthesia, my team members are going through the XGuide. It's about, I would say, about a 10-minute process to calibrate it and go through the data, because as I plan the cases in DTX clinic and then to DTX implant, once it transfers it, all that same data now lives in the XGuide unit. So I could also now manipulate the content, the data in XGuide. If you don't have DTX, you can always plan the cases yourself into XGuide. So you don't have to have another planning software. That's the beauty about XGuide, is you can just simply within that software plan it. Now I would say the graphics are not the same, but it does the job. Once the X guy is calibrated, the first thing I do is the patient sleep, anesthetize, and I go through and really we have to get the navigation arm for the calibration inserted into the jawbone, right? For the lower, we fixate that into the chin. So what I used to do was just make little small flaps, do that, calibrate, and then do the large flap. But now I just find it easy that go ahead and do a full thickness subperiosteal elevation from molar to molar. And really with the X guide, when we do our calibration, we have to make sure that we remove all the soft tissue, and we don't want to have any excess tissue because, fraction of millimeters counts in this case. So as I go through, and I find it easy to fixate the arm really, apical to the roots. You have options. You can do extraoral. Again, I don't do that. I do my intraoral. Sometimes I will do a stab incision, and I will actually put the EDX screws over my flap. In this case, I'm going to show you it's a full thickness flap. We're not displacing the whole mentalis. If you do that, then the patient gets the appearance of the witch's chin, which they get the droopiness. So we just make sure I reflect enough. I can see the root morphologies, and I can fixate the arm. So in this case, we've actually planned the case, and I know exactly where I'm going to go place these. Now, you can do this through navigation, or you can freehand, and that's your choice. So if you want to do navigation, you can plan it as a navigation and precisely put your initial osteotomies for the EDX screws. And in this case, I'm not using navigation. I am actually just freehanding, finding a spots based on where I planned it. I'm using a 2mm twist drill at 2000 RPM with a copious irrigation. You can see in upper left screen. That's really what I'm doing. I'm creating an osteotomy. That's really what it is. So for this, you have to have a full thickness flap elevation on the facial and on the lingual as well, so we don't damage any internal vasculation in the floor of the mouth. There's a hand driver where we can utilize to put the ADX screws. Once I place the first screw in, then I bring the arm in. And with the arm, really what I'm doing is I am inserting to find out where I'm going to place the second screw. And you have room, if anybody you guys hung any pictures in your house, and you really got to measure twice and cut once. This is really what we're doing. We're just finding an ideal spot to put the arm in. Once I do that, you can use a surgical pencil, you can use a burr, you can use anything to markate where the second screw is going to go. And that distance, you have about 10 to 14 millimeters space to go ahead and place the arm in. The nice thing with the arm is that these arms are bendable, and they actually are separated from, there's space of about 8 to 10 millimeters away from the teeth. So when I do that, it gives me wiggle room so I can actually extract around it. And that's key. And you can see I'm using my fingers there to put it in, but then I start using my wrist and my hand, because you really want to get a good fixation. This cannot move. In the upper left window, you see where I'm marking where I want to do this. So again, you have an option of doing this navigation, or you can do this just simply freehand. But the key is this cannot move. If this moves, you have to recalibrate, because like I said, either you're going to be accurately accurate or you're going to be accurately inaccurate. Once the arm is fixated, I kind of wiggle on it and make sure it does not move, and make sure it's out of my way as well. And as I do this, my recommendation for people who have not done this, first of all, be comfortable with the surgery, be comfortable with flap design, and you can practice this on mannequins, right? once you have this dialed in, it's really an easy process, and it's a repeatable process. That's why I love using the X-Guide, because you can repeat it. What I'm doing now is the bone mapping, and this we do it twice. The unit you see in my hand in the upper left window is the probe, which again, we're using the arm with the photogrammetry arm. It's reading the markings on the handpiece. And as you can see, I'm going tooth by tooth. As I'm looking inside the mouth, I'm looking and I'm finding points that these are fiduciary points. So I gave myself 3 points around across the arch. And we want these points to be, again, about 14, 18 millimeters apart. And what I'm doing is I want to be able to reproduce these points. So when I pick a point, I have to put the marker on it. As I put the marker, and the goal is to be less than a millimeter in accuracy. So when I do that, then I'm assuring that the rest of the surgery is going to be that accurate. Once that mold mapping is done, then we re-verify again, right? So not only do I do it on the teeth, then I do it on the bone. Once I do it with the probe, then I re-verify with my actual drill and with the guide, with the initial twist drill. Same thing. We pick the teeth that we picked, we go on it, and we make sure that as I go on the occlusal of a molar, it shows occlusal on the molar on the screen. If I was off, it would show that the drill is actually within the tooth or within the bone. Then what I do is, again, same thing. We go through and we touch the very surface of the teeth, and we touch the very surface of the bone. Then we verify that we're accurate, and we have a good merge. So, and again, this is actually slowed down, and this is just for teaching purposes. So it's not this slow. Once that's done, the flap's done. I especially having that arm there, I do not want to disturb the arm. So I do a lot of bone cuts. What does that mean? That means I use a 1 to 3 handpiece on a WNH motor at 180,000 RPM. And I use a 701 burr or 703 burr, where I just sectioning between, I'm removing an proximal bone between all the teeth, and again, going to the forcation of the molars. So makes the extraction much more predictable, much easier, and again, it's just less trauma, and it's just predictable. And this is really my routine, is using a 701 or 703 to do this, and by doing that, it makes the extraction much easier. The one thing you have to be careful, for the people who've done this, they'll agree with me. The people who have not done this, you cannot disturb the arm. It's simple as that. You cannot disturb that arm. If that arm moves or loosens up, then you're gonna have issues where you're gonna have to start all over again. Doesn't mean you have to bail out of your surgery. It's just, you just have to recalibrate. And what my thoughts in this is, for the people who have not done a navigation, is you can do about 10 cases where you're doing it with single teeth, multiple teeth. Once you get comfortable with that, then you can move to the full arch gamut and realize this way. Here, what you don't see here is, we actually, because this patient has such soft bone, right? Wide ridge, soft bone, and a lot of medullary space. For me, I decided that I'm going to fixate the EDX screws actually against some of the roots, or going through the roots. Well, what it does is it adds another layer to your procedure, because now, after the implants are placed, you got to take some more teeth out. So again, different workflows, different plans. It all has to do with your skill set and with your comfort zone. So here, I'm not taking all the teeth out. I'm taking most of the teeth out. And the teeth that I got to take out, the teeth that I got to take out, they're in my way, I may just cut them at the crest and then deliver them later. So again, reiterate, you can see the way the arm's designed. I can actually get around the arm and deliver this teeth without disturbing the arm. And if the arm is in your way, pre-surgery, you can try it in and actually bend these. That's the nice thing about this arm, is they're bendable and you can actually customize it to your own needs. Again, sorry if I'm boring you with extractions, but I just want to, point out again, that probably to me is the most challenging part with this is take your time with extraction, because I tell you what, the surgery just goes smooth. I think we timed the surgery from the initial osteotomy to the final implant placed. This case took us about 17 minutes. So it's smooth, it's predictable, and it's effective. And that's why I enjoy using the XNAV unit for my full arch. Do we use it for all the cases? No, but for the cases that I want predictable results and I want to be accurately accurate, I will use this unit. So once the extraction, we're almost done with extractions, once the extraction is done, then the next step is for me is to go through and we do alveoloplasty. Now in this case, we didn't show it, but my arm did hit the flap, and it's actually is screwed in, right? So what you want to do is just always verify, double check that the EDX screws are tight. And by doing that, you're assuring you're not going to have much issues with the calibration. And you'll know, because once you find a point in the jawbone and it does not look accurate on the screen, you're off. So there is a system check that goes through that. Extractions are done. And now what we're doing is that, we go through a plasty, and every time we go to a new drill, you have to verify your drill length. If your arm comes out of a field within 10 seconds, you have to re-verify. So the nice thing is the system itself, it does this so you're constantly double checking yourself, right? Now, if you're using the same drill for all sites, same implant length, you can always tell the unit that, hey, I'm using the same drill. By doing that, it will allow you to, so you don't have to verify drill length. Here, you can see really what I'm doing now is my focus is just on the screen, right? I have my XYZ axis. So it's giving me an axial view, a coronal view, and a sagittal view. So I'm just following the lines. And the nice thing, what I noticed when I did my first case with this was, I noticed that I had to expand my osteotomy site because you're not having that movement and the vibration that you would when you're freehand. When you're freehanding, even though you may be quick, you may be accurate, you're going in and out, but I tell you what, there's a lot more wiggle room, a lot more vibration. So the osteotomy sites seem to be wider. But in this case, I just find it that, we were, again, and this patient has really, again, you can see how wide the ridge is. And our goal is to get, a good stability by undersizing these. So it's allowing me to get close to the nerve. It's allowing me predictable. And you can see on the middle screen that, we're pushing the envelopes, but you can accurately place these implants in the precise spots that you planned them. So that's why I enjoy doing this. I've had the fortune of placing thousands of implants, done thousands of these full arches, but there's a joy when I do this because I know I'm on. I know I know what a lingual plate is. I know I'm right on a lingual plate to get that stability. I know I'm not going to perforate that plate. So that's why I enjoy utilizing this unit. And it's a learning curve. At the beginning, when we got the unit, it was just the team members, right? The team members get comfortable with it, and they're the ones that are setting everything up. Now, like I said, it adds about 10 to 15 minutes to our surgeries to calibrate the units. Once all the styling sites are done, again, I'm just probing the sites, I'm verifying, and make sure, again, there's no defects, there's no dehiscence, there's no fenestrations. And then we simply re-verify and measure the implants as well. So again, it's calibrated, and you can also navigate your implants in. Again, it's your choice. Some people choose not to because everything is tight, but here her bone was so soft that I just want to make sure I am placing my implants where I am. And we're getting, as you saw on the WNH unit, we're getting 30 plus newtons of torque on these implants. My goal for these cases, cross arch stability, is to get about 120 Newton. We've done some less, we've done some with more, but as long as I'm getting 120 Newtons of cross arch stability, I'm happy with that. And that's really, the workflow with the X-Guide. So CBCT, plan the case on either with your DTX clinic, or again, DTX implant, or you can just directly do this on the X-Guide itself. This one, just for one of the posterior implants, we just wanted to verify our placement. And again, having a software, we have one software in our office, and it, again, everything is stored in that same software. So with the DTX, I can just utilize the Nomad, and with the DEXA sensor, just take my PA and verify my placement and make sure I am where I plan to be. And again, the team members are on it, and it makes it easier for them. And here we're looking at placement, and again, nerve is nowhere on site. I used to use a lot longer implants. Now with the technology, and again with cross arch stability, I'm not doing as much bone reduction. I'm not putting as big as implants as we used to. So there's a little small change in paradigm, but we're still getting good results. Simply, once the surgery is done, I just simply remove the EDX screws. And the drivers for that, it looks like a hand drivers used for implants. The screws are about 2.7 millimeters wide. So they have a really good grip. They're very aggressive screws, but you need them. So you need them for this, for the stability. Once I remove the screws, then I may do a little bit of refining the edges of the bone around it. If there's any roots left behind, I will remove those roots. But in a nutshell, that's it. Once that's done, in this case, it's nice because I can put all straight multi-units. And the nice thing with that is I gain restorative space, because these are 1.5 millimeter height. If I was using these angled implants, then I'm going with 17 or 30 degree multi-units, which I'm adding height, and then I'm reducing my restorative space. The suturing I use here is a lot of times it's just chromic gut, and what we do is I do a combination of some bone sutures, where actually we put holes in the bone and we suture the tissue to the bone, so we get less movement. That's critical when we do our intraoral scanning. But you can see the heme control, you can see the precision, and again, it's a very predictable outcome. Now it's the restorative phase, right? So in this case, there was the only thing that was done is we had an initial scan, initial wax up, the digital wax up, which was done in ExoCAD. All the design that we do is in ExoCAD. I have my team member Goran, who does my designs for me. Here he does a pre-design, and what I'm doing is he knew exactly based on it how much bone was going to reduce. So everything was done to make sure, verify my video is exactly where I want it to be. So we'll try the prosthetic end, we'll check the bite, we check the VDO, we check the midline, make sure everything is good, because this is now a crucial step. If you're gonna do same day delivery, same day print, you got, again, it's garbage in, garbage out, guys. If you don't give your lab techs good data, they're gonna give you prosthetic that's just gonna be ill-fitting. So in this case, what I'm doing is I need to give him a bite and I need to give him a tissue scan. And here, what I'm doing is I want to make sure I can stabilize this and verify my video and make sure this doesn't work. So I use Blue Moose because, again, it sets fast and it gives me predictable results. We used to use Alginate. It distorts more. And again, to me, I just want something that works and is repeatable, reproducible. So I'm verifying the bite, I'm verifying occlusion. And now we had our pre-surgery, we had our video marked, and I'll verify to make sure that my video is still where it was before surgery. And again, sometimes it's a little bit tougher when they're sedated, especially if they're nasally intubated. So we verify, and I'm pretty close. I may be off a fraction of a millimeter, but I'm fairly close, so I'm comfortable. And we can always manipulate this also in exocad. So that's where, again, having a designer on site helps. Here we're using a Medit. This is a i700. And really all I'm doing now is doing a 360 scan, because I have my original bite from a pre-design that was done in exocad. So really all the design has to do is reintroduce this to his original wax up, and that will give him the VDO. And he will then merge the files, because I don't know if you know when you guys do exocad, is really what we're doing is you just have to connect the dots together. So here we've done the upper and lower ahead of time scan. We'll do an upper lower post-surgery and a bite. And these files will get sent to our designer. So the only thing to be missing is after that is the photogrammetry, which we'll go into second. Here, just for a backup, we are going to do a tissue scan. Now, this is challenging. This is challenging for all intraoral scanners. There's not one intraoral scanner that says it's the best. They all worked. Some work better, some work not as well. Here again, you notice we don't have much bleeding, and this is real time. You can see the Medit. It's working, but it's not, you're not going to get the scan in 30 seconds or even, a minute or two. Sometimes these may take 10 to 15 minutes, depending on the amount of heme. So what I do here is, a lot of tight suturing, bone suturing, and I use some cyanoacrylate, some tissue glue. So therefore, we don't have much bleeding, but this is key. But if you have a good 360 scan, you don't need to do this. But if you're using your prosthetic and you did a wash and the blue mousse was smudged, then you need to do a tissue scan. So now what we're doing is we are actually getting the bite now. And also what you notice, I've created some windows. So we cut some windows. So as we're scanning, I can also capture those multi-unit caps. So my designer can also use those to merge the files. So different ways, everybody does it different. There's not one right way. Some people use, I don't know if you've heard of breadcrumbs. Good friend Jonathan Abenheim came up with that term, because breadcrumbs is like Hansel and Gretel. And when they're in a forest, they want to find their way back. They had to, use breadcrumbs to find them back. So we would use these fixation screws. In this case, we did not do that. So I'm just using the data that's given to me here. I'm just capturing the bite, and we're merging this setup with this bite to the original wax up in exocad. Here, again, you can see We have the bite, so the bites merge. So I'm confident I'm going to get an accurate result and a good delivery with this. Once this is done, then we go into photogrammetry. And photogrammetry, if you think about it, is really giving you an accurate, it's a GPS, right? It's giving you your verification jig. We used to do this, we do pour mount returns, and we would pour against these all-on-4’s, send it to the lab, they'll make a jig, they would cut the jig, send it back to us. And what we would have to do is we would have to then verify it. Now with photogrammetry, this gets done in 30 seconds. This specific unit is an ICAM 4D. There's few right now in the market. You have your iPic, you have your PIC, and you have ICAM 4D. Different people like different ones. We chose this one. And I like the fact that it has to be calibrated every time you use it. I like the fact that diameters are small and are smaller. So it's just easier for my team members to use this. So once it's heated up, we're calibrating a unit. The calibration takes 10 to 15 seconds. Then we simply go through, and we like to get about 36 or so photos. And the unit itself everything will turn green. Once everything's turned green on the screen, you captured everything you need. And these files will get sent to our designer, and the designer will then merge all the data together so it can give us our bite, we can give us our video, and everything is then precise. The photogrammetry is, again, this is the video was slowed down just for teaching purposes. It does not take that long. What happens is once everything is captured, then the photogrammetry will actually in its library has the same caps that I use in the mouth. So if you're a Nobel customer, you use Nobel white multi-units, you just use that library, right? Because here you can see it's exporting these files, it's showing the files as these squares. But in reality, what is in the mouth are the multi-unit, white multi-unit caps. So what we have to do is go in the library and tell the software that, you know what? We have our implant positioning within the 8 to 10 micron. Why don't you export these out as these caps? If you're a different implant, if you use different implant company, then you can put that library in here. So when it does that, it will give you that, because that is important. Because once these files are exported in ExoCAD, we want to make sure we merge them. When you find the fiduciary points, they're merged together as same white caps. So that's what the team members do. They'll go through this and they do that. This, I would say, takes about the photogrammetry itself. I would say probably in the chairs about, by the time you enter the patient's name, choose the files, now you can see those files change, right? So now there are white caps. So that's how we will have the software export these out. So once it goes to ExoCAD, then the designer goes through, and these are layers, layers, and layers of files. You can see on the left-hand side, those are all the different files. Believe it or not, all the files. So they have to go through and virtually make sure that all these files have merged properly. Because if not, you might think you're dead on, but once you deliver, your bites off, midlines off, and you may have a cant, a tilt, a roll. So it's important to gather the data. And it's really, after surgery, it's all about data collection, right? And you want to have equipment that gives you predictable results and reproducible. So once this is all done, we'll go through and we'll look at the setup. We'll look at, and we then, after this is done, again, we won't know until this is delivered in the mouth. But first time I did this, you're always hesitant. because you're so used to chairside pickup. But now having the printers that can give you quality prints that are strong enough. And this is the exact setup that I have in my office. We have right now 4 of these Sprint Ray Pro 55s, and we have the Procure, and we use the Onyx resin. So once everything is done, just export as STL files, and it will go into the Rayware. And the software itself will actually give you the best positioning, and it will put the screws in, it will put those struts in for you. And so that way you get the best print. Here, Gabriel is our lab tech, and he's going through. And again, this is our case. This is step by step what we do on daily basis when these come up. Now, one of the most important things is once these come up, you have to get the resin off quickly, right? Because since we're going directly to multi-unit and those screw channels are so small, we got to make sure we wash those properly with alcohol and we dry them so we don't have any excess resin in the screw channels. Because if not, the prosthetic would not seat well. So again, this print itself takes about 45 minutes. The design for a single arch, since we already have a pre-design done, I would say it's about 15 to 20 minutes. So post-surgery, think about it this way. You have about half an hour for your intraoral scanning and for your photogrammetry. You have half an hour for design, so that's 1 hour. You have 45 minutes for print, so an hour, 45 minutes, and another 20 minutes to finish this. So about 2.5 hours you need to deliver. And again, it doesn't matter if it's a dual arch, single arch, it's about 2.5 to maybe 3 hours post-processing after surgery. So, in this case, the surgery took us all said and done, I would say about half an hour to 45 minutes for the surgery. So, the patient can choose to either stay for 2.5 hours, go home, come back that afternoon, or come back the next day. In my practice, we're averaging 8 to 9 arches a week. So it's easier for us if the patients come back the next day. So it's just easier for the team, and it's easier for the patient and our workflow. So once this is all done, then you can either deliver, it's depending on the smile line. If you want to go in and paint, then go paint. If you want to deliver as is, deliver as is. What Gabriel's doing right now is we're verifying to make sure the screw access holes have a perfect fit, right? Make sure that there is no blockage, make sure it's a passive fit. And that's key. And before we cure this, we put the lab analogs. And here, in this case, we're using the desk screws. So there's a library in the photogrammetry, right? So you have to choose a library, the right library for the right screw. So we use a library, and then when it exports it out for the print, so we have the right screw channel diameter for these screws. If not, if they're too loose, the screw will not engage. Too tight, again, not only won't engage, it'll be too loose, or if it's too tight, it just won't engage. You will not get any fixation. Glazing here, again, Gabriel is just going through. This probably takes about 5 to 10 minutes. The nice thing is with the new Procure 2, again, we're talking minutes. It used to take us an hour to cure these, but now for an all-on-4 type like this, it's about 4 to 5 minutes to cure it, and then after the final glazing, we'll do another cure. So the one thing you got to be really diligent with is where those supports are. We don't want to put the supports in the screw channels or on the incisal edges. So typically we put them on the linguals, but take your time and polish those properly, because if you over polish it, you're gonna throw off your occlusion. If you don't remove those properly, again, that's really is the calibration of your team members who are doing this for you. If you're doing it yourself, just pay really close attention as far as how you do your teeth setup and where those support structures are. Again, here in a Procure 2, again, it's just literally, it's minutes, and the prosthetic is cured and it'd be ready to deliver. So what we do is typically for these cases, I may go ahead and have a few, right? So the nice thing is when you have a few, then you always have a backup. First thing we do here is a Sheffield test to make sure we put one screw in and then we tighten it and then make sure there's no trampoline effect. The upper goes in and then the lower, and then I take a scan first, make sure I'm exactly where I need to be. And here, I'm just looking at pretty much each implant to see, did I place it exactly where I planned it? And you can see here, again, this is not an FP2, FP3. We can look at the posteriors. I may have maybe 10 millimeters of tooth structure. So again, not much bone reduction because there was no need. We're not getting many fractures with these. So as long as you have a good vertical dimensional occlusion, you have a good balanced occlusion, I don't have much fractures with the Onyx resin. Here again, I'm just going, again, implant by implant to make sure that where I put this implants in is really where I planned it. Again, you can see there was minimal bone reduction in the posterior, and we have hundreds of these now in the mouth. And here's Diana. I know.
Yeah, it's amazing. It's much amazing.
Yeah. No, I'm really happy for you. I'm really
I'm really happy for
Yeah.
me. Thank
Yeah.
you so much.
I absolutely love it.
I love it too. Thank you so much.
Absolutely. So that's really, at the end of the day it's about the patient's journey. And for me is, how can I deliver this day in, day out and be able to have predictable results? So again, having the right equipment, having the right team, having the right product and a workflow, it allows me to do this day in, day out. So thanks everyone for joining in. All right, is this used mainly to avoid inaccuracy with surgical stents? So here's my thing with surgical stents, right? And with surgical stents is, again, you're really depending on somebody who's designing that stent for you, right? And the material and the print, and you got to make sure, again, are you a seasoned surgeon? Is your first time doing it? So for me, I was always a freehand guy, and for me to create a stent, it takes longer for me to go and design a stent where I can use my X-Guide. Now the X-Guide costs more, but again, it also has photogrammetry. So I think that's something I would do in both, right? Try stents. If that works for you, then great. Because again, I've done stents, and most of the time they work great. So it just depends how busy a practice you have. This one is done. Let's see, meaning the stents becoming less accurate after exos and bone reduction. So when you do a surgical stents and you want a bone reduction guide, now you need other softwares, right? Because now either you've got to export everything out to Blue Sky Bio or have Exoplant to be able to design those. So now you need to have a designated team or have somebody who is going to do that for you. For me, I want to do everything in-house. So having the X-Guide helps me do that. Next question. With all of these post-surgical prosthetic procedures, there is no problem of wound infection. So again, it's you have to keep a clean field, right? So if you think about what we used to do chairside pickups with acrylic flowing into our surgical wounds. Even though that we're suturing, we're putting a rubber dam, but some of that material does leach in. I mean, the body is amazing, it has such high blood supply. So no, when I was at the homeless shelter, I mean, we would do thousands of these. I mean, I would do courses at the homeless shelter. We would do 300-400 implants in 3-4 day course. and doing chairside pickups and conversions. So no, not much problems. Now you can't leave debris behind, so you got to make sure you clean the wound. But part of it is again just good irrigation. How do I get started? My thing is, if you're already doing surgeries, great. If you're not, then there's courses all over the country. I teach all-on-4 courses, and also I teach full digital courses. So get comfortable with surgery first. Second thing is having the equipment and the software. You need a CBCT, you need an intraoral scanner, you need photogrammetry. You have to look at the cost. You got to look at how many patients you're going to see and what is your return on investment. So I would talk to your reps or talk to friends or just direct, message me directly, and I will walk you through really, what the protocol, should be. Name of manufacturer. Well, manufacturer for the CBCT I use is the OP3D, was Cabo, now it's all under the DEXIS family. So we all know DEXIS as a sensor, but now Envista, who owns DEXIS, is really your CBCTs, your intraoral scanners, your sensors, your intraoral cameras. That's under the DEXIS brand. My intraoral scanners, I have 3Shape and I have Medit. My photogrammetry is iCam. I have a Roland mill, and I have also IMS iCore mill, and we have sprint rate printers on X-resin. Next question. Thanks for the presentation. Do you use a smile design software pre-op to show? Great question. Yes, we use Smilify. So I use Smilify, and it's my team members. My team members do that, and they just simply take a photo, and you can three-dimensionally design it with Smilify, and then you can simply just export it to Exocad, and it's exactly the same design you send out. So you don't have to manipulate it. So that's what I use for that. The list of equipment and the courses to be fully functional. Again, equipment we just discussed, CBCT, intraoral scanning of your choice, photogrammetry, either iMetric or PIC. Hopefully by end of the year, X-Guide will have that as a photogrammetry unit where you would use ELO scan bodies. And then again, the mills and printers, a printer, I use a Sprint Ray for that. How long do you leave your patients in this prosthetics? How often do you rely during healing? So we have cases when we go to final the next day. We have cases where some of the population, you have to think about function and aesthetics and headaches. I don't want them breaking these. So a lot of times I may print 4 sets of these and have it. And just if they break it or damage it, they can come in and get a new one. I've only had a handful of fractures, and those had to be with just parafunctional habits. But the Onyx resin, the Sprint Ray, that is FDA approved for 9 months. So healing time, typically if I go to final, 4 months, I'm really happy. Do you have patients return in a few months for final prosthesis with zirconia? Yes. Some cases, we went through a process with Facebook, we're doing all zirconia, but I just don't think that's appropriate for all patients. Sometimes we do temple bars, sometimes we will do a PMMA wrap on a titanium bar, or we'll just do a titanium bar with the zirconia shell. So typically, like I said, my wait time is minimum 3 months. I use Trios, iCam 4D, Rosen Screw, Flexera Smile, OptiGlaze, AutoFlash. I find glaze wears off too fast, even with pels. So again, so for me is, that is something. So in my practice is we all have roles. I do the surgeries. Dr. Roy does a restorative. My lab takes care of that. That is something I can get back to you, Chris, on this one as far as the glaze. So again, for me, it's easier to print 3-4 of these at once, and then so then if something is wearing off on me, then it's an aesthetics issue. I just simply have them remove it and I just deliver a new one. Because again, end of the day, the heavy lifting is done. You just have about $15 in resin. So So, but you can message me directly and I'll tell you what my lab techs use to get the glaze stay longer. These dentures look quite simple to design and finish. How did you compare to one you would get from the lab? So what we used to get from the lab were actually dentures that we would convert. So the dentures we convert, they were a denture that we would just cut the flanges off, do a chairside pickup. I was not a big fan. I would get a lot of fractures just because now you're soldering acrylic to composite for pickup to titanium. And the fractures would come around where the cylinders are. And for those, I would have to have 15 millimeters in height and 15 millimeters in width. Thick, bulky, poor speech for patients. So we decided just to do the printing. So again, the design is, yes, if you have ExoCAD, it's not the design, it's merging and manipulating the files. So if you have a good designer, I think you'll have great success. Do you have to use Nobel products? No, you do not need to use Nobel products to use DTX Studio. It's open. That's the beauty about DTX. It's open. So you can import in and you can export out. Do you mill out of the final prosthetic immediately after surgery? Yes, we just to verify, even for our own good, we actually print and mill to verify our prints because we want to make sure we always calibrate. So what I'll do is not only I'll print, I also will mill a PMMA. Again, these are all direct to multi-unit. And again, you can use disc screws, you can use Dr. Rosen screws, or you can use Jonathan's Powerball screws. And how often do you give Onyx patients night guards? Every time. So all my patients get night guards. X-Guide. I've never seen X-Guide before. What's the approximate cost to get started? X-Guide was about 30,000 to 35,000. Think about it. You'll get a navigation unit, and you're getting your handpiece. I think a lot of times now you can get a promo deals, talk to your Nobel reps, and they will go through with that. To me, as somebody who's getting started, it's a great unit because, again, you're actually accurate. Just confirm that you're not using temp abutments in your temp bridge. Just screw the print out exactly. We're going directly to MUA. We do that for and even for our finals. We do not, because the nice thing is when you do it this way, you're actually getting some extra restore space. And I think that's it for all the questions. Absolutely, it's been a pleasure. Anybody want to get a hold of me? Sorry, my last slide wasn't there. You can on Instagram, Meranfar Dental Group, at Meranfar Dental Group, MEHRANFAR Dental Group, or Implant ED Edco, Implant Education Company. So be glad to answer any questions, or you can just email me at mjoemeranfar@gmail.com.